Thank you, Andy. So let me see if we get the slides up here. OK, they are up there. Thank you and welcome. I'm going to talk about democratizing access to Spark. And you've heard us speak here before, and we've told you that we created Databricks to simplify big data. So by that, I mean that we wanted to enable more people in organizations to be able to ask questions from data. So we wanted to democratize access to Spark. Not just have it be the few people who know how to configure these systems, set up clusters, and write these complicated programs. And towards this, I'm going to make an announcement in this talk that I'm really excited about. But it's towards the end of the talk. Before that, I want to talk about the journey that we've had over the last 2 years with Databricks and Spark. So when we started Databricks, we decided to host the platform in the cloud. And the reason we did that was that we were really excited about these 3 things. One, the hosted model allows us to configure everything for you and make sure that it works end to end. Second, we could have rapid releases. That means we could get our software out in the hands of customers every other week or every week. And the main benefit of that, of course, is that you can get feedback on the features that you're releasing. So you can iterate and learn from your mistakes much faster than if you have to build shrink-wrapped software that you have to ship every 6 months and then hope that people upgrade to that version of the software. And then finally, it enables a dynamic use case. So you can spin up environments and deploy your use cases whenever you need to. If you need 100 machines for 3 hours, you can do that. You can also compose your abstractions because there are already other companies that are providing you services in the cloud. So it's much more dynamic in that sense. So let me talk about the platform that we built and that we GA'd last summer at Spark Summit West. So the Databricks platform comes with open source Spark. And outside of this, we also built a lot of integrations. These were features like security, governance, auditing, multi-tenancy, production jobs. These were features that we had to build for the first time in the cloud around Spark. So we did that, and they're table stakes for many enterprises. On top of this, towards this goal of democratizing access, we also built an integrated workspace. The integrated workspace enabled users to collaborate, comment, and visualize, plot, and talk directly to Spark. And all of this, of course, whether it's you can run it on top of any storage system that you have. So Spark is great at federating the queries down to Hadoop or data warehouses, or more frequently these days, storage that you have in the cloud. So let me talk a little bit about how it's used so far. And I'm going to tell you about 3 use cases that we've seen. The first use case is what I call a just-in-time data warehouse. And over 80% of our customers use this use case. And what this really means is that you separate compute from storage. So Hadoop, in the early days, would combine the two. But what we do here is that we separate them. You store your data, often in the cloud, in a very elastic way. And you pay for whatever you're storing there, and it's very reliable. Simultaneously, you use the Databricks platform to launch clusters with Spark and extract insights from those. And that can be very efficient and dynamic. So I've listed here that 3 out of the 10 top mass media companies use this. And what they were able to do is take ideas that they had and get it all the way up to an app in much shorter time. So they could shorten this from months or weeks, sometimes down to days. The second use case is on top of the just-in-time data warehouse. And it's the advanced analytics use case. And this is very common. So oftentimes, companies will use machine learning or graph processing to build richer models and do advanced analytics. So Radius Intelligence has a talk this afternoon that's really exciting. They'll talk about how they build a very complex model using machine learning of 20 million companies out there in the world. And the final use case is a use case we see more and more, especially this year. There's a lot of excitement around real time, and you heard Matej's talk. We're doubling down on that in Spark 2.0. And here you simply build data products that are working on real-time streams. And they can combine batch, real-time, and all the other libraries that are in Spark. Here we have a top 5 credit card company that's doing loan approval in real time. So it means people apply for loans, and in real time, it'll run machine learning and figure out whether it should approve or decline that loan. Okay, so what's the main lesson? So we've had hundreds of customers now that have used Databricks platform, and what have we learned during this time? So the main lesson is that while we've solved the technology bottleneck, there's still a human bottleneck. So companies still struggle with big data projects, and the main reason that we see is that there's a really steep learning curve for developers. It's still hard to learn this stuff. And the reason for this is, historically, development, you would do it on your own machine or in your own environment. But here, because of big data, you have to do the development close to the data. Otherwise, it won't make sense. And that's really costly and time-consuming. So a lot of people struggle with, first, they have to acquire machines, pay hundreds or thousands of dollars to just get those. Then they have to set them up and configure those machines, which can take a lot of time. And then finally, to build the actual applications, they have to go through and stitch together many apps, and there might be poor documentation, and they struggle with this. So how can we get around this? How can we empower more developers to get access and insights from big data? So in 2014, we set out to train people and help them overcome these hurdles. So our goal was ambitious, and we wanted to train 2,000 people. And I think we hit that towards the end of the year, and we were really happy. And in 2015, we tried something a little bit different. We launched 2 massive online open courses, MOOCs, and we were overwhelmed by the numbers. 125,000 people took our courses, and over 20,000 finished the course end to end. And it was an accumulated over 500,000 hours spent just learning Spark. So we were very humbled by this, and we wanted to double down on this. So we're thinking, how can we multiply this and democratize access to Spark? And this brings me to the announcement I mentioned earlier. So I'm proud to announce that today we'll be releasing Databricks Community Edition. What is Databricks Community Edition? It's a free edition of Databricks Spark platform. You'll get access to mini Spark clusters. These are clusters that you can freely use. You'll get notebooks, dashboards, the collaborative features that we mentioned earlier, and the APIs that I mentioned. But more importantly, you also get continuous delivery of content that we'll be uploading there. So you will already have access to the courses and the MOOCs that I said. That's already uploaded there. And we'll be uploading also how-tos and documentations. And this actually uses a different version of what we trained on in the last couple of days. OK. Right. And that's a Databricks logo with a community building up around it. So I'm really happy to say that today, every attendee that's here gets access to this. And on top of this, we're going to make it really seamless for organizations to transition if they want bigger clusters than those mini clusters I mentioned, or if they want to build production pipelines, or get access to any of those enterprise features like security and governance. We're going to make it easy for you to set up your own accounts, put in credit card information, and upgrade to the other professional and enterprise tiers. OK, so without further ado, I want to welcome on stage Michael Armbruster to do a demo of Databricks Community Edition. Michael is one of the main committers on the Spark project. He's the lead on SQL, so welcome.
Thank you very much, Ali. I am super excited to be here today to show all of you guys some of the really cool things that you are all going to be able to do using Databricks Community Edition. As you can see, we've got my email inbox up here, and I've received my invite to join the beta program. Everybody in the audience should be getting this throughout the day. And for those of you who are watching this on the live stream, I encourage you to head over to databricks.com where you can sign up for the waitlist. We're going to be trying to expand this beta program as quickly as possible. So all you have to do once you get this email is click to activate your account. It's going to take you through a sign-up flow. And after that, it's going to drop you into your own personal copy of Databricks. This is your one-stop shop for creating Spark clusters, creating interactive notebooks, and learning about Spark in general. As Ali said, this is pre-populated with a whole bunch of educational content. So if you just head over to the workspace, you can start with the basics in the Databricks guide. This kind of gives you all of the details of using Databricks itself, how to create a Spark cluster, how to create a notebook, and even advanced topics like how to take a data frame and create an interactive visualization with it. For those of you who are just getting started with Spark, we've also got you covered. If you go back to the workspace, you'll see that we've actually got an entire college course about learning Apache Spark. This is an award-winning, massive, open online course taught by Anthony Joseph out of UC Berkeley called Introduction to Big Data with Apache Spark. We've integrated it into the workspace. So all you have to do is click on it, and you can see all of the lectures as YouTube videos that you can work through at your own pace. And really, it's even more than just watching a bunch of videos. This is a fully interactive experience. So if you click on one of the labs, you'll see that this is also an interactive notebook. And if I want to actually follow along and test my Spark knowledge, all I have to do is click on Import Notebook. And what it's going to do is it's actually going to take a copy of this and move it into my home folder inside of Databricks. And so once I've done that, I can actually go to any of the cells that contain code, and I can hit Shift-Enter to run it. And you'll notice as soon as I did that, what it did was it actually attached me to one of the Spark clusters that was already running in the cloud. So that's pretty cool. But personally, when I try to learn something new, the way I like to do it is to just dive in and start analyzing some data. And when you're working with a big data product like Spark, sometimes it's difficult to find an interesting data set to get started with. But fortunately, Databricks is actually preloaded with a bunch of cool data sets. One that I think is particularly interesting is the Wikipedia clickstream data. So again, if I click on this, it's going to take all of the code that I need to access this data set and clone it into my home directory, into a notebook. And what you'll see is, let me kind of describe what this data set is all about. So this is a data set that was released by the Wikimedia Foundation. It contains aggregate statistics about all 3.2 billion requests that Wikipedia received during the month of February 2015. So just a year ago, all of the requests from Wikipedia. And what they've done is they've actually aggregated it down into source and destination pairs. So you can actually track the flow of traffic through Wikipedia, how people are clicking from page to page. As an example, let's look at a visualization of what the data looks like for the New York City Wikipedia page. So as you can see, a majority of the traffic comes from Google, which is kind of unsurprising. But another major source of traffic is the New York State Wikipedia page. And then, similarly, if we look at where people go once they're on this page, they click on other related topics like New York, Manhattan, United States. So now we understand this data set. Let's actually dive in and take a look at it. So you'll see the first line of code here actually loads the data set from the Databricks file system. It's already pre-populated, and we've converted it into an efficient format Parquet so we can read it pretty quickly. So again, as soon as I hit Shift-Enter, it attached me to my cluster. And now we can actually take a look and see what the records of this data set look like. So we'll do display clicks. And it's going to run a short Spark job. And you can see an example of the kind of data that we're going to be working with. So you can see what this is telling us is that 52 people clicked from the article Valley Parade to the list of accidents and disasters by death toll, which is pretty heavy reading. OK, pretty cool. So now let's try asking some more complicated statistics about this. I'm in particular curious about the flow of traffic within Wikipedia itself. So I'm going to use Markdown to explain what I'm doing as I go along. We'll say, what % of clicks from other wiki pages? So this is pretty easy to calculate using data frames. We'll start by calculating the total number of clicks in the data set. Clicks, and we'll calculate a sum of all the n, and then we'll tell Spark to run that job, and then get the first entry. And then to calculate the clicks from within Wikipedia, we'll do wiki clicks equals, and we'll take this same code here, except this time we'll apply a filter to remove clicks that are coming from other sources. So where prev ID is not null, so where we actually know the page that it's coming from. So now that we've got these two numbers, calculating the percentage is pretty easy. We'll just do wiki clicks divided by all clicks, and then multiply by 100 to make it a percentage. And so as soon as I hit Shift-Enter, it's actually firing off a distributed Spark job. It's running in the background. You can see that it's actually taken that data set and it's split it up into 39 pieces. And if we click on View, we can get a better idea about what's actually going on under the covers. It's actually doing this calculation in two different phases. One phase that is calculating the sums for each of the individual partitions, and then it's doing an exchange or a shuffle, which is collecting all the data into one place, and then calculating the total sum for all of the pages. If we look at the next job that's running, we can see it's doing something very similar, but this time it's also doing a filter to remove all of the clicks that aren't coming from Wikipedia. So pretty cool. And what we learned here is that actually 33% of the traffic from Wikipedia is coming from Wikipedia itself. That's pretty cool. A lot of people just clicking on through the web, which I know is something I can get lost doing for a while. But that actually took a while. That took, as you can see here at the bottom, that took 37 seconds to run. And Matej was talking this morning about a bunch of really cool performance improvements that are on the horizon. I think it'd be pretty cool if we could actually play around with those. So typically, using the bleeding edge versions of Spark require you to go to the Apache website, download the code, compile it, deploy it to your cluster. But fortunately, in Databricks, it's a little bit easier. I've actually pre-started a cluster running Spark 2.0. So I'll go up to the clusters menu, and I'll detach my notebook. And all I have to do is attach it instead to the Spark 2.0 cluster. And now we can ask the question, how much faster is Spark 2.0? Hopefully faster. So now that I've attached to the cluster, all we have to do is reload the data set. And then I can take exactly the same code that I was running before, and we'll paste it down here, and we'll hit run. And so it looks like it's going faster. And if we actually dive in and look at the details, you can see exactly what Matej was talking about in his keynote. This whole stage code gen has actually fused all of the different operators together into one very efficient operation that's taking advantage of all of the modern features in CPUs today. And so as you can see, that actually took 13 seconds, so pretty fast. Cool. So now that we're on a hyper-optimized version of Spark, let's move forward with our analysis. So the next thing I want to do is I want to select an interesting set of pages. And we can do this using SQL. Since Spark is a unified platform, we can actually kind of switch back and forth between different programming paradigms based on what's the best tool for any given job. So we'll say select star from clicks, and let's do some filtering here. So first of all, I'd like to exclude Google. I want to zone in on just the things that are coming from Wikipedia. So we'll say where prev title not like, and then we'll exclude anything that starts with other. So that's any of the search engines. We'll also exclude traffic from the main page. Does not equal main page. And now let's actually zone in on a specific set of articles. So we'll say cur title in, and let's pick something topical, maybe Donald Trump. T-R-U-M-P. And we probably don't want all of the clicks to the page. That'll be pretty hard to visualize. Let's just take the top ones. So we'll say order by n, so the order by the number of clicks, and we'll limit it to just the top 20. And so you can see here are the top refers to the Donald Trump webpage. So now we've got this, but I actually want to do a cool visualization with it. And to be perfectly honest, I'm actually not a very good JavaScript programmer. So I'm going to do what any good programmer does, and I'm going to go to Google. And I'm going to type in Spark, SQL, data frame, force, directed graph, D3. So just kind of some keywords about the type of visualization I'd like to make. And we'll see, oh, that's convenient. There's a link at the top. And it just so happens that there's an example of how to create this kind of graph with Spark SQL. And if this looks familiar, that's because it should. This is actually a notebook that has been published to the internet. And the coolest part about being a notebook, instead of just some fragment of code that you find on Stack Overflow, is it's actually really easy for us to take this and import it into our Databricks workspace. So this looks like a pretty cool visualization that I'd like to use. So if I just click Import Notebook here, it's going to give me a URL. And I can copy this URL and head back over to my workspace. And in my home directory, I can click Import. And we'll paste the URL. And what Databricks is going to do is it's actually going to go and download that HTML, parse it, and take the code and insert it into my workspace. And as you can see, there's actually kind of more than meets the eye here. We can actually see there's an entire library of code to create this visualization. So now that we've got that, let's actually just copy it and take it back to our original analysis where we can use it. I'm going to go here, paste it, and hit run. And now that library has been compiled and loaded into my cluster. So now we've got a bunch of results from a SQL query, and we've got this Scala library for doing visualization. We need to combine the two. And normally this would take a fair amount of boilerplate to translate the rows into the correct format. But as Matej again was talking about this morning, there's a pretty cool feature that we debuted in Spark 1.6, but we're improving a lot in Spark 2.0 called datasets. So just to kind of visualize exactly what I'm talking about, let's pull up an image here. And so what you can see is data sets are actually a really nice bridge between the semi-structured relational world and the type-safe object-oriented world. So if I just take the sample code from here, and we'll copy it, and then I can take my SQL query from above, and we'll just insert it here as the set of clicks. So equals SQL. And all I have to do to translate it into this edge format that this library is expecting is say as edge. And when I hit enter, Spark is actually going to do a mapping. It's going to tell me, do these column names line up? Do I know how to map this data? And if it doesn't, it'll provide a helpful error message about how to fix it. So in this case, it's telling me I need to tell it which column is the source. So let's provide that mapping. So we'll say the previous title is the source. The current title is the destination. And n is the count. So now we hit Shift Enter. We have our visualization. And Donald Trump is in the center, exactly where he'd want to be. So let's expand it to a couple more candidates. Hillary Rodham Clinton. And let's also add Bernie Sanders and hit Shift Enter again. And you can see now it's actually, and let's make this a little bit bigger so we can see the whole thing. Now you can actually see, we can actually see the interrelations between the candidates as visualized by clicks on Wikipedia. So we've got Hillary over here, and you can see that the United States presidential election, even a year ago, was a major source of traffic for all three of these Wikipedia articles. And then other candidates, both Bernie and Hillary actually share a bunch of traffic from the Democratic Party presidential candidates. So pretty cool that you can see this, even a year ago in this data set. So now that I've got a pretty cool visualization, though, I'd like to share it with some of my friends. And fortunately, collaboration is built in as a first-class feature inside of Databricks Community Edition. So I'm going to go over to Settings, and I'm going to add a user. So invite my friend Miles here, Databricks.com, and send him an invitation. And so in Miles's inbox, he should have gotten an invitation to come and join my workspace. In the Community Edition, you can only share your workspace with 3 people, but you can actually be invited to an unlimited number of different workspaces. So this is a great way to collaborate on different types of data analyses that you might be doing. So if we go back over to this Wikipedia clickstream article here, and we can see that Miles has actually joined my workbook, and down at the bottom, I think he's already started to do some cool visualizations. And it looks like he's studying hipsters, which are strongly associated with Brooklyn. Cool, okay, so that's pretty nice. And sharing with Miles was great, but there's a lot of people here, and I'd actually like to share this analysis more widely. I'd like to share it with the whole world. And this is, I think, actually probably the coolest feature of the Community Edition, is the ability to take any notebook that you've created, you can click Publish, and what it's done is it's actually sent it out to the internet, a static copy of this, and it's giving me a URL that I can share publicly with anybody in the world. So if I copy this over here, I can now go over to Twitter. I can say, check out the demo from #SparkSummit Community Edition. And we'll paste that right there, and I will tweet it. So now you all have access to that code, and you can do your own visualization. So if we click on this, just to see exactly what it ends up looking like, it's actually an exact copy of this, statically published as HTML that anybody can look at. So pretty cool. And here comes my favorite part of the demo, the part where we let all of you loose on Databricks Community Edition and see all the cool things you can do. So thank you very much.